Hello students, how we doing? Oh, thanks. Yeah, I'm doing good too. Thanks for asking. You didn't ask. You never ask. You never say anything. You don't want to sound awkward talking to a video screen. Well, I'm doing it right now, so why can't you? It's okay. It's okay. All right, chapter 5, college math. Ready for our test. Let's try along here. This might help you prepare for some of the questions on the test. Not necessarily everything, but definitely some of them. So number 1 is going to be one of our exponent. Made a pretty gnarly one just for you to practice. Number 2 is going to be the finding the domain and range of these particular functions. And I know we haven't gone into it that hard, but remember the domain is all the x values, the range is all the y values, and the strategy is going to be to graph each one. Number 3 is going to be some multiplying, expanding those two terms. But wait, there's more. Number 4 is going to be, number 4 and 5 are going to be some more expanding, some foiling, getting a little trickier. And then number 6 is going to be finding some different products and quotients, excuse me, and some sums and differences and some composition of some functions. So again, these are try-along videos. The idea is you can pause the video right now, try these problems. I'll scroll to the next one in just a second. Pause it now. And there's number 4, 5, and 6. Try it, and I'm going to go solve it, and you can compare your answers to mine. Okay, so number 1, here we go. When you look at this problem, okay, we have negative exponents. By the way, this is a 9, not a Q. We have negative exponents, and we also have parentheses. So step number 1 when you do these is you want to distribute everything using the parentheses. So this top term here, let's not forget that this 2 is going to get multiplied into each. This 3 is going to get multiplied into each, including the 3 and the Q, and same thing here with this negative 2, but it doesn't go to the 9 in front, it just is going to go to all those. So let's start out and do that. So I'm going to have p to the negative 4th, q to the positive 8th, and then I'm going to have 3 to the 3rd, and then I'm going to have p to the negative 3rd, and then lastly, did I write over it? I think q is just by itself, right? So that's going to be q to the 3rd. Over the bottom, now I'm going to do something a little crazy here because I'm that kind of crazy. Hopefully we recognize that 9 is 3 squared, so I'm going to write it as a factor of 3. Why? Because I have a factor of 3 on the top. And then p negative 1 times negative 2 is positive 2, and negative 2 times negative 6, sorry, positive 3 times negative 2 is negative 6. Okay, so that's going to be step number 1. Step number 2, let's combine everything we can in the numerator and denominator. So we have 3 to the 3rd. Let's see what happened to the p's. We can add those together. So we have p to the negative 7 and q to the 11th. Did I combine everything? Looks like it. And then on the denominator, we're going to have, well, we didn't really do anything to the denominator, so there's that. Okay, now my little trick here is what I do next is I take everything that was a negative exponent and I put it on the bottom, and making it positive. So in other words, this p to the negative 7 can go to the bottom as p to the positive 7. The q to the 11 can stay on the numerator. 3 squared could stay on the denominator. Then I also had that p squared down there, but then that q to the negative 6 can go to the top. Now once I have that, let's just reduce what I can. Not a whole lot. I have 3 3's on the top, 2 3's on the bottom, so I'm going to be left over with 1 3 on the top. I have 17 total q's on the numerator, and I have 9 p's on the denominator. And there it is. That's as simple as we can get it. Way more simple than that, right? Sure is. Did you get that answer? Good. Good job. So number 2 now, we're going to find the domain and range of those two functions. Now when you do these domains and range, remember the domain is all possible x values, the range is all possible y values. So I want you to think of the graph here of how this looks. So let's recall that I'm about to just in red do the parent function here of just a regular parabola like y equals x squared. Well, let's look at a, the function in a. Well, I'm going to do 2 times this. What's going to happen if I multiply 2 times it? Well, it's going to make it steeper. It's not going to do a whole lot, just the 2 by itself. We'll get to the minus 3 part later. But this, for instance, would be 2x squared. So the last thing we're going to do now is take that same 2x squared minus 3, I'm sorry, that same 2x squared, and then we're going to take away 3 units of it, so 1, 2, 3. So we're going to have this function in green there. So for part A, the domain, and this is going to be true with all polynomials, the domain is just all real numbers. It's from negative infinity to positive infinity. But what about the range? What y values does this function encompass? Well, it definitely, from everything from 3 and up, it goes from 3 and up, negative 3 and up, excuse me. But notice that the y is never less than negative 3. So the range in this case would be from negative and 3, and also, so I got to erase this because it does actually include negative 3, because when x is exactly 0, y is exactly negative 3. But it goes on to infinity and beyond. So that was part A. I'm going to erase this graph over here. Bye-bye. Bye. Bye. Okay. So how about part B? What's the domain and range of this one? Well, if you recall, I said x cubed looks like this. It goes right through the origin, and like any polynomial, still going to be true of any polynomial, the domain is, sorry, and this is just x cubed without the minus 3. But this is this easy. Any polynomial, x can be any value you want, because I could square any number I want, I can cube any number I want, I can multiply, I can cube a number by 3, sorry, I could cube a number, multiply it by 3, and subtract 2 of the square of the number, and it's no problem. There's no restriction on our x values. So we look at this x cubed minus 3, and it's just going to take every single point here on x cubed and move it down 3 units. Well, remember, if I cube a negative number, I get a negative number as a result. Unlike part A, when we squared a number, even if I square a negative number, it becomes positive. Well, it's going to be true that the range, since if I cube a number, a negative number, I still get a negative number, the range is going to be all real numbers as well. And there's going to be a nice little fact that we could learn here. For polynomials, if the highest power, the degree of the polynomial, is odd, both the domain and the range are going to be all real numbers. If it's even, like part A, even degree polynomial, then the domain will still be all real numbers, but the range, we have to be a little bit careful. I'm not going to put a rule to it, because if it's negative, it might go downwards, but we have to be a little more careful where the range is. And what we really need is the vertex. Like the last problem, the vertex was down here, but maybe later we can complicate things a little bit and maybe have a upside down parabola or something like that. But we'll complicate that later. How'd you do on that problem? A+? Great. Let's go to the next one. So the next problem, we're expanding 3x minus 4y times 3x plus 4y. Now I could do this the long way, but the idea is that you're going to use the shortcut that I taught you, which is this is a difference of squares. This is an a minus b times a plus b, and we said that that equals, what did it equal again? Good, a squared minus b squared. So if I realize it's in that form, I mean, I could FOIL it all out, but I'm a lazy guy. Let's just get to the answer quickly, right? This is going to be 3x quantity squared, which is going to mean I have to square the 3 as well as the x, minus 4y squared, which means I'm also going to have to square the 4 as well as the y. So this is going to be 9 squared minus 16y squared. And it's nice, these difference of squares always cancel out that middle term. I think we saw that when you actually did them by hand. And if you don't believe me, FOIL it out the long way. The middle term should cancel out. Okay, good, you believe me now. Alright, let's try number 4 here. Number 4, this one looks kind of gnarly. So we have to be a little bit careful. This is not a difference of squares. This is not a minus b times a plus b. This is a squaring a binomial, or actually a trinomial in this case. So unfortunately, I'm going to have to FOIL this one out pretty much the long way. There is a shortcut to do a binomial, but this is a trinomial. So no matter which way I try, I'm probably just going to have to do this the long way. So that means that this, I have to FOIL, but this is a little bit more than a FOIL. So this 3x goes into each term. Then the 2y is going to have to go into each term. And then lastly, the 1 is going to have to go into each term. So let's see what happens. You a little nervous on this one? I am too. So 3x times 3x is going to give me 9x squared. Then I'm going to have 3x times 2y is going to be plus 6xy. And then 3x plus 1 out here will just be plus 3x. Now my 3x has gone into all 3 terms, so now my 2y has to go into all 2 terms. So 6x plus 2y, sorry, 6x times 6, 2y plus 3x, I just had the answer in my head already, is going to be 6xy. 2y plus 2y times 2y is going to give me 4y squared. And then 2y plus times 1, it'll give me plus 2y. I'm not done. I have to do my last plus 1 here. And multiplying anything by 1 is easy, because you can see it's just going to be the same the last term. So now let's combine all my like terms. I have 9x squared. I'm going to put my 4... I'm not going to care which order you put this in, but I'm going to put my 4y squared next. I have a few xy terms, 6xy and another 6xy, so that's going to give me 12xy. Now I'll take all my just regular x terms, and it looks like I have 6 x's. And I'll take all my y's, and I have 4 y's together, and lastly just plus 1. That wasn't that bad, was it? Horrible? Hated it? Worst time of your life? Don't worry, the class only gets easier from here on out. Just kidding, it's math, dude. What'd you expect? Alright, so that's number 4. Hopefully that went well. Hopefully you tried number 5, because I'm about to answer it. Okay, here's number 5. Expand this guy. Now instead of it being squared, it's being cubed. And we have to be careful. This does not equal, you can't just cube each term. Not the same. Nope, 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 nope. Just forget I did that. I can't do that. This is really a foiling problem times 2. So this is the same as 3x plus 2y times 3x plus 2y times 3x plus 2y. So I'm going to FOIL these two at a time. Sorry, I'm just going to pick two of these, say these two, and FOIL these. So hopefully you're getting better at this. 9x squared plus 6xy plus another 6xy plus 4y squared. And that's all going to be still multiplied by that last one that I didn't throw in yet. Let's combine like terms. That's a y. Plus 4y squared times 3x plus 2y. So now that the like terms here were combined, I'll factor that, I'll FOIL this out again. So I'm going to have 27x cubed plus 18x squared y. I just put the 9x squared into both terms. Now I'm going to put the 12xy into both terms, so that's going to give me 36x squared y plus 24xy squared. Now put the last term in, so that's going to be 12xy squared, and then my last term will be 8y cubed. I ran out of room there, but that's at 8y cubed. So lastly, let's combine like terms. So 27x cubed plus, oh man, what's 18 plus 36? 54, right? 54x squared y. And then how many xy squared terms that I have? 24 plus 12 is 36 xy squared. And then lastly, plus 8y cubed. Did want to point out something here. Just hypothetically saying, if this was a multiple choice question, maybe there's ways you could eliminate answers. Check this out, 3x and 2y. Notice this term right there is indeed 3x quantity cubed. Again, that's 3 cubed, 27 times x cubed. And this term here is my last term, 2y quantity cubed. The only thing that happens is all this stuff in the middle can get a little bit messier. So you can definitely eliminate answers if it were a multiple choice question by just going, hey, which one's 3? This first term, for instance, should be 3x cubed. This last term should be 2y cubed, quantity cubed. That includes cubing the 3 and cubing the 2, respectively. Last problem, save the worst for last, best for last, depends how you look at it. Okay, so here we have our f, g, and h. So we have to find f times g in part A, fog of b in part B, in h, in c, h minus f, and in d, h divided by g. So let's start with part A. For part A, we're doing f dot g of x. Now just remember, that's the same thing as just f of x times g of x. So if I look at f of x, 2x squared plus x minus 1 times x minus 1, I just need to FOIL this out. So I have 2x cubed minus 2x squared plus x squared minus x again plus 1. So this should get us 2x cubed minus x squared minus 2x plus 1. There, that wasn't that bad, was it? Oh, it was? I'm sorry. Don't worry, it gets easier. Part B, we have to fog. Go to the next screen here. So part B, we have to fog of x. That's a g. It's so hard to write in my stylus, sorry. So again, by definition, fog of x is f of g of x. Well, this one's a little tricky, but that means everywhere there's an x in f, I have to replace that with g of x, x minus 1. So if we look at, say, the 2x squared, well, what's going to go in x squared? Sorry, what's going to be substituted as x? It's g of x. So again, I just literally put this in for that, and I have to do that again here. Plus x minus 1, and then minus the second one on the outside. So now I have to FOIL that out. Hopefully you remember this trick that a minus b is a squared minus 2ab plus b squared. So this is going to give me x squared minus 2x plus 1 plus quantity x minus 1 minus 1. Distribute everything out. I got 2x squared minus 4x plus 2 plus x minus 1 minus 1. Combine like terms, and I got 2x squared minus 3x, let's see, plus 2 minus 2, so that's it. This plus 2 and the 2 minus 2's cancel each other out. We're almost done. Sorry, we're almost halfway done. Sorry, we're almost a quarter of the way done. Nah, just kidding. We're almost done. So we're doing h minus f. So part C was to do h minus f of x. So again, these are simple, more simple, because this is just literally defined as h of x minus f of x. So I could just take my whole h of x term expression and subtract f of x and remember, when we're subtracting, it's kind of like turning this to addition and then switching all the signs here. So that would become a negative and that would become a positive. So now we can just combine like terms. Well, there's no x to the fourth terms. There's no x cubed terms. Okay, we had a positive 2x, and we're actually now subtracting negative 2x, I'm sorry, the positive 2x squared minus negative 2x squared, sorry, minus 2x squared is just going to eliminate the x squared terms. Then I have a minus x and a minus x again, so I'm actually going to have minus 2x, and then plus 3 plus 1 will give me plus 4. That wasn't that bad, right? That was awful? I'm sorry. It's math, what did you expect? Last part we're doing h divided by g, so let's finally getting into our long division here. Alright, so last part, part D, h divided by g of x. So again, this is just defined as h of x divided by g of x, and that means I'm going to have to put g of x into h of x, so this is going to require some long division. I think I'm going to go to my next screen to give me more room to write all this. So I had x minus 1 all into 4x to the fourth minus 4x cubed. So I have to go back and look at it. Plus 2x squared minus x, and it was plus 3, right? Yeah, plus 3. Okay, here we go. You excited? I'm going to use some Christmas colors here. So again, I want to eliminate this first term, 4x to the fourth, and I have to go x times what is going to equal 4x to the fourth? Well, that's going to be 4x cubed. So now again, when I am multiplying 4x cubed into this entire term right there. So that's going to give me 4x to the fourth minus 4x cubed. And now I am going to subtract these away. So again, this subtraction sign out in front, weirdos. This subtraction sign in the front is going to change the sign here. In other words, I just eliminated all my x cubes. So there's no x cubes. So I have to bring down my next term, 2x squared. But really now, since I eliminated my x cubed as well, I really need to bring down two terms. And if you see, that would make sense in this case, because if I were to try to eliminate that 2x squared, well, I mean, okay, I should already recognize I'm going to have to add 2x to this. I would have had, if I didn't pull down this minus x right there, I would have had another x term. In other words, you know, when eliminating this this one right here, I'm multiplying by 2x, so that's going to give me 2x squared minus 2x. If I would have gotten to this step, and had I not, say, brought that minus x down, what am I going to do with this minus x, the minus 2x right there? Yeah, nobody knows. So that's why I have to bring down both. All right, so negative x minus negative 2x is going to give me a positive x. Again, just change that to addition. Your life will be a lot easier, or switch the sign on that. And then plus x3. How many times is x minus 1 going to go into that? Well, just one time. And I'll have x minus 1. Subtracting, so that's going to give me a remainder of 4. So I'm going to add up here 4 divided by my divisor, which was x minus 1. And that's my answer up there in green. Boy, you've wasted a perfectly good 26.5 minutes listening to me talk, all my bad jokes, and my cats who were sitting on my lap the whole time barely made a noise, except for like 2 minutes ago. All right, happy studying, and I'm available for office hours if you need me.